Okay, welcome to Warm-Up 12, Day 10. These are our answers, and so as always, go ahead and pause the video right here to be able to check your answers. And then when you press play, we will come back to the screen to work through the problems. All right. So one angle in a pair of complementary angles is 5 times greater than the other angle. What are the measures of the angles? Well, the first thing we need to remember, complementary means the two angles equal 90 degrees. So angle 1 plus angle 2 is 90 degrees. Now we know that we've got one angle, let's call x. The other angle is 5 times greater, so that would be 5x. So angle 1 we can put as x. Angle 2 we can put as 5x equals 90. Now x plus 5x, remember we assume that there's a little 1 in front of here, so 1x plus 5x equals 6x. And then if I want to get the x by itself, I need to divide by 6 on both sides. So x equals 15. So that's one of my angles. Now there's two ways that I can go about finding it for the second one. I know one angle is x and one angle is 5x. So 5x would be 5 times 15, which is 75. So that's one way to find my second angle. I also know that the two angles together equal 90. So 90 minus one angle would give me the answer for my second angle. So whether I find it like this or I find it like this, either way, once I found my first angle, I can find my second angle. So number 1, the answers are A and F. Number 2 is looking at a transformation. Remember, we always want to look at where we are starting, in this case, figure A, and where we are finishing, figure A1. So what does it take to get this shape to be this shape? So we have some rotations, which are turns. We have translations, which are moving left or right or up or down. Well, we want to look at our lines and at our angles. So we know our short line is here and our long line is here on this shape. And in our second shape, our short line is here and our long line is here. So there needs to be some kind of a turn happening. A translation, either moving this figure 6 units this way, well, that's not going to work, or 6 units this way. Neither one of those is going to change the position of our short line and our long line. So translations are not going to work. So we're looking at either a rotation of 360 degrees or a rotation of 180 degrees. Well, we know if we go from one point and we rotate 90 degrees, let me do it this way. If I take this shape and I rotate it 90 degrees, then I'm going to end up with this shape. So I took it and I turned it once 90 degrees that way. Now if I take this shape and I turn it again another 90 degrees, that's going to give me that shape. So that is what I want. One 90-degree turn here and one 90-degree turn here. So that's going to give me turning 180 degrees. If I would turn it 360 degrees, it would be back where I started. Okay, so that is 1 and 2. Let's look at 3 and 4. Which value is between 4 and 5? So remember, if you have got numbers looking one way in your question, here they're whole numbers, and numbers looking a different way in your answers, here we've got square roots. We want to transform the numbers in our question to look like the numbers in our answer. So 4 is the square root of 16, because remember, the square root of something is what number times itself equals that number inside the radical. And then once we've got a 4 and a 4, that tells us the answer is 4. 4 times 4 is 16. So instead of 4, we could say which value is between the square root of 16 and 5 is equal to the square root of 25. Because remember, if we've got a perfect square underneath the radical, we just see what number times itself equals that number, and that's our answer. So instead of saying 5, we can say the square root of 25. And now, if I'm looking for which value is between the square root of 16 and the square root of 25, the answer is obviously the square root of 17. For number 4, which set of dimensions cannot be used to form a right rectangular prism with a volume of 36 cubic inches? Well, we know rectangular prisms volume equals the area of the base times the height. So we want to know which of these 4 will the area of the base times height not equal 36. Well, for letter A, 6 times 6 is 36. 9 times 4 is 36. 12 times 3 is 36. And 13 times 2 is 26. So this is the one that cannot be used to form a right rectangular prism with a volume of 36 cubic inches. Okay, number 5. 467,382 rounded to the nearest 10,000. So this 7 is our thousandth spot. This 6 is our 10,000. But remember, whenever we're looking at rounding, this 6 is the number we want to decide if we're changing or not. This 7 is what determines whether we change. So if this number behind our rounded number is 5, or more, then this number goes up. So 7 is more than 5. So we want to take this 7 and go up 1. 470,000. Okay, number 6, negative 6.5 divided by 2.25. If I don't have a calculator and I notice that all of my answers are in fractions, then I want to take these decimals and I want to convert them to fractions. So negative 6.5 is the same as negative 6 and 5/10, which we can reduce to negative 6 and a half. Divided by 2.25 would be 2 and 25/100, which we can also say is 2 and 1/4. Okay, so now what we're looking at is negative 6 and a half divided by 2 and 1/4. But I want to take these mixed numbers and I want to make them into improper fractions. So remember, my denominator stays the same, and to find my new numerator, I take my whole number 6 and I multiply it by my denominator. So 6 times 2 is 12, plus my old numerator, which is 1. So 12 plus 1 gives me my new numerator, 13. And I need to keep my negative sign. Same thing, my denominator stays the same. 2 times 4 is 8, plus 1 is 9. So now I'm at negative 13 and a half divided by 9/4. If I'm dividing a fraction, it's the same thing as multiplying by its reciprocal. So if I'm going to multiply, I notice that I can take a 2 out of these. I can reduce. So now I have negative 13 times 2 would be negative 26 over 1 times 9, which is 9. Then to get it back into a mixed number, my whole number is negative 26 divided by 9, which is negative 2. My denominator stays the same as 9. And then my new numerator is my remainder. So negative 2 times 9 is 18. 26 minus 18 is 8. So negative 2 and 8/9. Okay, number 7. Which animal is farthest from sea level? This is a distance problem. And distance is always positive. We use the absolute value of our numbers. So my absolute value of positive 480 is still 480. My absolute value of 400 is still 400. But my absolute value of negative 650 is a positive 650. And my absolute value of negative 420 is a positive 420. Because whether I'm above sea level or below sea level, which is what these positives and negatives mean, I am still that many feet from the sea. So even at negative 650, which would be 650 feet below sea level, I'm still 650 feet. So the animal that's farthest from sea level is the octopus. Okay, number 8. Probability value indicates an event is unlikely to happen. Probability values are always positive. So right there, I can see that -1 and -4/10 are not going to be right. Then if I want an event that's unlikely to happen, I want the smaller number. So between 0.75 and 0.2, this is the smaller number. If that's confusing to you, remember 0.75 and 0.2, we can put another 0 on the end. And then we're comparing 75 and 20. So we know that 20 is less than 75. Number 9 is just seeing, do you know how to read the graph? So at this point, 2, 600, I'll be right there. What's happening? Well, 2 means we have 2 donors, and our total amount of blood is 600 milliliters. So 2 donors yield 600 milliliters of blood. Last one. Okay, so for number 10, we are wanting to match the graphs to the descriptions. So the easiest thing to see is which 2 are linear and which 2 are nonlinear. Well, we know the linear ones are graph 1 and graph 4. Those are our straight lines. Our nonlinear are our curves. And those are graphs 2 and 3. So, decreasing linear function, I'm looking for the line that is going down and to the right. So between 1 and 4, graph number 1 is going down and to the right. Increasing linear function means I'm going up and to the right. So the one that's going up and to the right and is still a line is number 4. Decreasing nonlinear means I'm looking for a curve that goes down and to the left or down and to the right, which would be number 2. And an increasing nonlinear function, I'm looking for a curve that's going up and to the right. So that would be number 3. And that is our warm-up for today. Hope you guys are having a great day. And let me know if you need anything. Remember to ask Miss Laura for questions that you have that my answers aren't making sense to you. And yeah, hope you're doing well. Talk to you soon.